with today's lesson. We're on the green. You've got some new derivatives to learn, and they are pretty intuitive. And so, as I often do, as I did yesterday, I said, okay, the question of the day is, well, here's the question of the day. If you have an exponential function, find the derivative. Go. Feel free to talk it over to math and English. Got it? Cool. Give me something I can do to help me get there. Natural log of both sides. I heard somebody say log base 2 of both sides, and that's totally logical. What's the roadblock then you run into?
Log 2.
Yeah, you don't know the derivative of log base 2 either. That's in today's lesson, and we haven't done it yet. So that is a great idea, but it doesn't go anywhere. So instead, let's do natural log. I love that you took the natural log. Anytime you want to bring the exponent down, that's a good thing to do. And then what did you do?
Multiply by n.
No, you don't mean to say that. Oh, I don't think you said that. You better unsay that.
I didn't say it.
Okay. Because that to me is like saying, I want to solve this by dividing out the square root. That's not. So log is a function. You know. Okay. So go ahead. What else can you do? Good luck. You want to take the derivative. So take the derivative implicitly. I take the derivative with respect to x of both sides. Then what's the derivative with respect to x of natural log of what? 1 over y dy dx. And the derivative with respect to x of x natural log of 2. Is that a product rule case? Why isn't it a product rule? Natural log of 2 is constant. What if I did use the product rule? Would it still be okay? Yeah, because the derivative of log of 2 would be 0, and that's all good, but that's a silly waste of time. So it is just natural log of 2, I think you'll agree. Now what do I do? Multiply by y. Now, yesterday we talked about how if the original problem is in x terms, then the derivative should probably be in x terms. So we can't leave it there. We're going to put in place of y,
2 to the x.
2 to the x. Okay, oops. Natural log of 2 to the x, natural log of 2, or whatever order you want to write it in. Boom. Now, extending that to more generally, what do you think the derivative of any base to the x is? The x natural log of 8. Now, unless I say in the homework, develop the derivative of, then feel free to just recall. All right, you with me? All right. Let's try a similar question. Will you now figure out how to take the derivative of log of another base? Again, feel free to work with your math amigos. Ready? Okay, give me something I can do. Okay, so let's exponentiate 2 to the y equals x. Then what can you do? Okay, you could actually take the derivative of that because we do know now that. I think maybe that's a little funky. What else could you do? Natural log of both sides. Which means, I don't know why I'm doing this up here. Why don't I do it down here? That's stupid. Y natural log of 2 equals natural log of x, yeah?
Yeah.
Did you move the log 2 first, then differentiate, or differentiate now?
Differentiate now.
Okay. So do you get dy dx is times log of 2 is 1 over x. So dy dx is 1 over x natural log of 2. Okay. So then, generally we could say if log base 2 of x's derivative was 1 over x log 2, natural log 2, then generally speaking, the derivative of log base a is over x natural log of whatever the base. Alright? Alright. Apparently there's nothing on this side visible. What the heck? Did I lose a slide? Oh, is this a question for you?
Yes.
Oh, okay. Show analytically and graphically why this must be negative. Please, go. All right, so can you agree that the derivative is 1 over x natural log of a half?
Yes.
Why must this be negative? Okay, what must x be? X must be positive because the log of the domain of log is positive zone, period. All right, so x must be greater than 0. Log of a half is negative or less than 0. So altogether it indeed has to be negative. Think graphically. Notice we know that log of something with a base greater than 1 looks like this. Log base greater than 1. What about log base less than 1? It goes this way. So doesn't it stand to reason then that the derivative would have to be negative? The slopes are negative. If Follow? Alrighty then. I feel like I am missing a slide here. Something about absolute value, yes?
Yes.
That's a pity. I don't have that. Hang on 1 minute. Absolute 72. Sorry. Okay, here we go. Okie dokie, people. So, third idea of the day, a lot of little nibbling kind of ideas, are absolute value derivatives. You can sum up the approach to absolute value in one word. Now you do this in a piecewise kind of way. So, let me look at this. First of all, let me communicate that the derivative on the absolute value of x squared minus 4 is 100% not just absolute value of 2x. That would be great, but it's a big fat no. Okay? You'll see in a second why that's just not happening. So let's talk about the graph. What does the graph look like, please? A parabola that would normally be shifted down 4, but instead of the thing being allowed to have negative y values, the y parts are flipped up, so we have a local max at 0, 4, and that's it. You follow me? Now, every absolute value can be written as a piecewise function. I'm going to go left to right. That's pretty standard. So for the left side, for x is less than negative 2, what's the function out here? Did that part get changed from normal parabolic behavior?
No.
Okay, so there is no change here. So what's the function out there? X squared minus 4. All right. What about between negative 2 and 2? Yeah, those would normally be negative y's, but we made them positive. So we took the opposite of f here, and so isn't this, as the man said, the opposite? So 4 minus x squared. Does that check at x equals 0? Would you get a positive 4? Yeah. Okay. And what about the far right branch? No change. So that's back to x squared minus 4. Now what about the flex points? Are they included? Yes? Yeah, why not? Okay, so do I include them here and there, or in the insides, or everywhere? Or, all right, does it matter if I go insides or outsides?
No.
But can I do them both?
No.
Okay, so either way it's good. It's going to make a famous. All right. Now then, let's say we take the derivative. Well, the derivative of a piecewise function is a piecewise function. What's the derivative of the left-hand branch? 2x, for x is less than negative 2. What's the derivative of the inside branch? Negative 2x. Between negative 2 and 2. Well, what's the derivative of the right-hand branch? For x greater than 2. Now, include them on the same in the inside?
Oh.
Why not?
Doesn't at all exist.
Yeah. Do not include on the derivative because there is a sharp turn. Often, would you please put the word often? There's a sharp turn at the flex points. Not every time. Sometimes there's a smooth transition. Can you give me an example of a function that would actually, upon flipping, be smooth and the derivative would still exist? X what? Cubed. Beautiful. If you took the derivative, or if you looked at the graph on this, wouldn't it normally go flat there and here, but with the absolute value it would be here? But is it a hard turn there, or is it smooth? And so the derivative would actually exist in that case, and that's why I say off. All right. Now, that said, the key to taking derivative of of absolute value is piecewise. So would you give this a go? Please find the derivative on the quantity, the absolute value of x minus 1 cubed. Okay? No, okay. Okay, somebody who's done and we're waiting. What part got flipped? The part below 1 or after 1? Below 1. So for x is less than 1, the function is the opposite of x minus 1 quantity cubed, yeah? And for x is greater than 1, there was no change, so normal x minus 1 quantity cubed. Okay, and so taking the, and on the original function is 1 included? Yeah, there's a point there, okay, it's equal to, it's got to be included in one of those two places, right? All right, now when I take the derivative, the chain rule, negative 3 times x minus 1 quantity squared for x is less than 1. Do you agree with my derivative?
Yes.
And 3 times the quantity x minus 1 quantity squared for x is greater than 1. Shall I include it or not?
Yes.
Okay, at 0, or sorry, at 1, isn't this derivative smooth? At 1, f prime here is 0, and at 1, f prime here is 0, which is to say that the left-hand, right-hand slopes are matching. And so is there a sharp turn if the slopes match on both sides?
No.
No, okay. So if the one-sided derivatives, and I didn't use the definition of the derivative like we, if we had a proof problem. One-sided derivatives match, then it is smooth at x equal 1. So I do include it. The derivative does exist at 1. And again, does it matter which one? No, it's the same for either side, but in order to be consistent, doesn't it feel like you should match the first one, so I'm going to include it there. So do include x equal 1 here. If it's smooth, then you get it. You with me?
Yes.
Alrighty then. Let's try an EBT on this bad boy here. How embarrassing. How embarrassing. If I didn't do it 3 times a day myself, I would be so mortified. All right, so find the absolute extreme of this absolute value function using the EBT, and we'll confirm with the graph. So, what is the EBT? And let's just, let's go min and max. Absolute extrema must occur at critical points or endpoints. All right, so surely the meat of the problem then is the derivative work. Before we take the derivative, though, we're going to rephrase this as a piecewise function. So, doggone it, maybe I need a graph here, but let's see. Let's find the zeros, I guess. 1 plus 2 sine of x. Isn't it all about the zeros because that's what's going to do its flipping?
Yes.
Okay, so 1 plus 2 sine of x is 0 at sine of negative 1/2. And where is sine equal to negative 1/2? Pi over 7 pi over 6 and 11 pi over 6, yay? Are you with me? Unless I made a mistake. Do you agree? Okay. All right. And what about the sign of this? Is it positive or negative? In between, from 0 to 7 pi over 6, is this going to come out positive or negative? Positive. So from 0 to 7 pi over 6, we are saying that's positive. So am I going to use the opposite of the function or the normal old function? Normal old function. So 1 plus 2 sine of x. Okay? From 7 pi over 6, technically to 11 pi over 6, but really to 3 pi over 2, I'm cutting it off that. So from 7 pi over 6 to 3 pi over 2, that's normally negative, but now I'm flipping it up. So what's the function in that territory? Negative 1. Do I negate both or just the first one? Both. Okay. There's my function. Let's talk derivative. What is the derivative of 1 plus 2 sine of x? 2 cosine of x. And what is the derivative of negative 1 minus 2 sine of x? Okay. What about at 0? Am I good to go? Is this being flipped at 0? No. So does the derivative exist at 0?
Yes.
Yes. So I think I'm cool there. What about at 7 pi over 6? It feels like that's a flipping, and the derivatives are going to be different on both sides because cosine of 7 pi over 6 and negative cosine of 7 pi over 6 are different. Yeah, they're different. Okay. So, yeah, okay. I don't know what I'm thinking so much about. So 7 pi over 6 is not included because the derivative doesn't exist. And 7 pi over 6 to 3 pi over 2. And does the derivative exist at 3 pi over 2? It does. That's not a flex point, so include it. All right, and so where are our critical numbers? Critical numbers are where the derivative is 0 or undefined. So what about that? The derivative is 0 at x equal, where is this guy 0? Okay, so now you're making me sad. Where's cosine 0? Okay, are you just being shy, or what the heck? Why did you not speak? And what about this? Where's this guy 0? They're both 0, pi over 2 and 3 pi over 2, right? The 3 pi over 2 is kind of covered with the endpoint. I guess if you want to include it, fine. But it's, again, an endpoint. So that's f prime is 0 there. What about f prime d and e? F prime is undefined at, what causes it to be undefined? Sharp turn. Do I have a sharp turn here? Yeah, it's 7 pi over 6. There's a sharp turn. All right, so I have really 2 critical numbers and 2 endpoints, or 4 candidates altogether. Do you agree? All right, so let's go with f at 0. What is f at 0? The absolute value of 1 plus 2 sine 0 is 1. F at, what's the next one I come to? Pi over 2 is the next, I believe. 1 plus 2 sine pi over 2, what's that equal to? 3. F at, what's next? 7 pi over 6. That feels like it's a flex point, so it feels like that's where it should be flipping, and this should be 0. But let's see. What is the sine of 7 pi over 6? Negative 1/2 times 2 is negative 1, and 1 is 0. Cool. And what about f at 3 pi over 2? 1 plus 2 sine of 3 pi over 2, rather. And what does that come out to? All right. So from that, we conclude that the absolute min value of f is 0. That stands to reason. Absolute value definitely couldn't be negative. It doesn't have to be 0. I guess it could always be positive in there. Absolute max value of f is what? Okay, and if you wanted to include the inequality, you surely could. It's gravy and it's good math. I didn't do it. All right. If I were to confirm this with the graph, then let's start by graphing the normal sinusoid. What does the 1 do? Shifts it up 1, so it's centered at 1. What does the 2 do? Amplitude. Now the amplitude would go up to 3 and down to normally -1, yeah? You follow? Okay. Normal shape of a sinusoid is center line up, like that. They only said from 0 to 3 pi over 2. So let's dump this part. And then if we flip, then this part actually gets something like that, okay? So let's locate these points on a graph. Isn't this 0? That's an endpoint and a good candidate. This is pi over 2. What's this flex point? Where's that flipping happening? 7 pi over 6. And this is a candidate, but it didn't turn out to be big enough. 3 pi over 2. All right. If it doesn't say, if there's no directions in the homework, then you may do it either way, graphically or analytically. Most people say graphically. Do either way. Okay? Understood?
Yes.
Cool. So without looking at your notes, what's the derivative of a to the x? X times log of a. What's the derivative of log base a of x? And what's the key word to taking the derivative of absolute values? All right, right on. All right, questions on the homework from last night? 71. Is there any humdingers in here? 11 was a bit of a humdinger. I don't know if anybody wants that one. Was there any other one that was rough? Oh, there's 10. 10 sandwiched down. I don't know if I made you do that one. 17. Any questions? Sorry, I'm just talking. Nothing? Oh, you're real quiet. Oh, just shout them out, please. Go. 1. 11. 10. 15. 6. Did you say 16? Yes. Okay, cool. We can get through a lot more if you just say, hey, I had a problem with this or that. So on 70 number 1, they had this beam problem, and my biggest issue was how do I get the variables down here? So I think the radius was 6, and therefore the diameter was 12. I think they called this D and this W. The strength equation, which I would love to hear how this is developed. I'm not familiar with this equation, but the strength relates to the width and depth of the beam and some constant K, which I imagine relates to the material itself. But we're trying to maximize strength. General rule of optimization is, can you get the number of variables down to 2? Variables down to 2 by substitution. 2. So what's the key idea to get the variables down to 2? What's another relationship between W and D that is going on besides this strength equation? So use Pythagorean theorem. D squared plus W squared is 12 squared, so 144. I saw d squared in there, so I said, well, shoot, that sounds good. D squared is 144 minus w squared. And so that's what I put in there. So now my equation is a much cleaner kw 144 minus w squared, or 144 kw minus kw cubed. Keep in mind the k is a constant, so don't sweat that. Now I said, all right, now my calculus. I want to find where the derivative s prime or ds dw goes positive to negative. So take the derivative. It's 144k minus 3kw squared. Set it equal to 0, which allows you to dump the k. And so maybe something like w squared is 48, I think. So w is 4 root 3. And I feel like before this would be less, so positive. I feel like that is a mess. That's good. You with me? Okay. 11. Is 11 still a question? All right. 11 is a bit of a humdinger. By far the most important part is that actually, so you might have said, well, let me try U sub, and I hope you found that if you tried U sub, it was a no-go because there was a power match or this mismatch or whatever. So what is the overall strategy here? Trying to make it arc sine, all right? Arc sine is this basic idea, 1 minus x, 1 minus u squared du is arc sine u. Okay? Now then, the 3 is a non-issue. I can put that up front. And the next issue is the 25. You want to make that a 1 and do it by factoring. So I factor out a 25, leaving me with 1 minus 9/25 x to the 4th. And if I then further square root that 25 and pull it all the way up front, I get this kind of thing. Are you with me on what I did? Okay. Now we're ready to do our u substitution. I actually do more of a u squared substitution. This needs to be u squared. So u squared is 9/25 x to the 4th, which means u is 3/5 x squared. And therefore du is 6/5 x dx. Are you tracking? And that means x dx is 5/6 du. Now I'm ready to substitute like crazy. 3/5 is cool. Here we go. What goes in place of x dx? 5/6 du. 5/6 du. What goes in place of 9/25 x to the 4th? U squared. And so I get something like 1/2 arc sine of u, and what is u? U is right there, 3/5 x squared. Right. So first of all, you have to recognize it as arc sine, and then be able to manipulate it to make it right. You follow? All right. Maybe I can at least get us started on 10, maybe. Okay. The idea is one of sandwich theorem. If you graph negative absolute value of x, it's a downward opening V, eh? If you graph positive absolute value of x, it's a upward opening V. And they said, what if you graph x sine 1 over x, which is kind of funky. And I had no idea what that looks like, but it looks like this. All right? Well then, if I want to know what is the limit as x goes to 0 of x sine of 1 over x, then doesn't it have to be above the blue graph, and therefore above the limit as x goes to 0 of negative absolute value of x, and below the red graph? which is less than all values approaching absolute value. Okay? So as x goes to 0, what does this go to? 0. What does this go to? 0. And so it gets squeezed, and it's got to be 0. Alright, that's the idea. At least we got through some of it. I'll be here after school if you have questions on 15 and 16. Those are good questions to practice for the test. Have a nice day. Can I record this? Yeah.